Hello engineers, welcome back. In the previous video, we got the theoretical understanding about disjoint sets, right? In this video, let's implement it in C++ and then we can understand it deeper, right? So let's get started. So quick recap, what did we do? So in order to make a disjoint set, we need two things, a parent array and a size array. And initially the parent array will have the values of themselves. So 0 will have 0, 1 will have 1 and so on. And size will be 1 for everything. And that was our initial start position, right? And then we implement two things, find method and union method. Find will always return the root, okay? Root means parent of itself. And when we need to perform union, we will use this logic, smaller size goes to bigger size. So we will compare the two sizes of the elements and whichever is smaller will be attached to the bigger sized elements, right? And during find, we will see how to implement path compression. Okay, so let's get started. Let's go to VS Code. So I am now in VS Code and I have created a new file called disjointsites.cpp and I have the base template so we can get started. So let's create our class. Let's call it disjoint set. And then we will need our two vectors. First is the parent vector and then the size vector. So let's create them in the private space. Parent and size. And in the public space, let's create our constructor first. This will take in a value which will be the number of nodes. And we will resize our vectors based on this number of nodes. So parent vector dot resize to the size n, and also the size vector should be resized to the size of n. And because we know the elements of the size vector, we can initialize everything with 1. Okay. Now we need to initialize the parent vector as well. As we discussed, every element in the parent vector will be itself. So let's create a loop for int I equal to 0, I less than n, I plus plus, and we will simply say parent of I equal to I. So every element will be itself. So this is our start position. Now let's implement the find method. So what do we need? For find, we are saying we need to return root. Root means parent of itself. So the find method will return int, which will be the parent, and this will take in a value. We are asking who is the parent of x. So we need to return parent of x, but we need to return the root. We will only return parent of x if the parent of x is itself. Otherwise, we will do recursion and keep finding the root. So if parent of x not equal to x, we need to do recursion and keep going up the tree. Okay. So if we don't find a parent which is of itself, we will go up the tree and find the parent of the parent. Then we will repeat the process until we find a value where parent of x will be equal to x and we will return that. Okay. And this is where we perform path compression. So whenever we are doing this recursion process, as we discussed in the previous video, whenever we are doing this recursion process, when we are going to find a new root through the recursion like this, and once we find it, we will pass it down the tree so that we update it, right? So we'll look at this example. We are finding the parent of Ben, parent of B. Parent of B is not equal to B, so we went to Charlie. Parent of Charlie is not equal to C, so we went to Ben. And then we found that parent of Ben is Ben. And then we passed down Ben down the tree and updated Ben everywhere down the tree. So we will simply do that here. We will say parent of x equal to find of parent. So what is happening here? So this find is doing the recursion thing. It will keep on going until we find the parent. Once we find the parent, we are returning the parent, right? that parent will be updated to the descendants in the tree, so that next time when we call find, it will directly return this one. It's an instant operation, right? So that's how path compression works. Now let's implement the union method. Union will be void union set. It will take in two things, x comma y. Okay, and then we are asking, how did we do this union process? First we asked who is the parent of Sam, and then we asked who is the parent of Tom. If both are different, then we check the sizes. Whichever is smaller, we will make the bigger one the parent of the smaller one, right? So that is the logic. Union set. First we ask who is the parent of x. So int root x, who is the root parent of x. So go and find x, and then same thing for the y. Find y. So this will go into our public method find, and we will do all these recursion steps until we find the root of both of them. Now we check, is it the same or not? If root x not equal to root y, then we need to perform union, and union will be by size. So here we check if size of root x is less than size of root y, then what do? We found out that root y's size is bigger, so x will be attached to y. So parent of x will be root of y. Okay, parent of x will be root of y. So whichever is smaller size goes to bigger size, right? So for example, if we are comparing Sam and Ben, and Sam is bigger, right? So Ben's parent will be Sam. We will update Ben's parent with Sam's index, right? So that's what we are doing here. Parent of x will become root y. Okay, and we will also update the size. Size of root y will be plus equal to size of root x. So what will we do next? Once we attach this, whatever is in the Ben's size will be added to Sam's size, so that if we are attaching this component to this component, we are getting 3 more values. So 3 will get added to Sam, right? So we're just updating the size here. So this is the case where size of root x is smaller than root y. Otherwise we will do the opposite. Simple. Parent of y will become root x, and size of root x plus equal to root y. Okay, we have just done the opposite side, and that's it. Now we are ready to use our disjoint set. So let's create our set, disjoint set ds. Now we will add our edges. So we had 5 edges, right? We will add these 5 edges and pass it to our union method, and union method will check using find method who are the parents. If there are different parents, it will perform union, and after the whole edges are traversed, we will have a parent array which we can then use to ask such questions: are Sam and Charlie friends or not, right? So let's see. So ds dot union, so we need to pass in the 2 vertices. So who is the first edge between Sam and Tom, right? So this is 0, 1. And then we have an edge between Sam and Jerry. This is 0, 2. And then we have an edge between Jerry and Harry. This is 2, 3. And then we have an edge between Ben and Stuart, which is 4, 5. And then we have an edge between 4, 6, which is Ben and Charlie, right? So this is our set. Now after doing all this, we will have a parent array which is updated and which caters to all these edges. Now we can ask the question, are Sam and Charlie friends? So we will ask if ds dot find Sam, which is 0, equal to ds dot find Charlie, which is at 6. If both of them are equal, we will say both are friends. Otherwise, we will say not friends. And that's it. So what is happening here? We are asking who is the parent of Sam, and we are asking who is the parent of Charlie. If they have the same parent, if they have the same root, which means that they belong to the same component, which means there is some way to reach each other. So we will call them as friends. Otherwise, we will call them as not friends. So that is our whole implementation. Now let's run and see. Oh, we need to pass in the number of vertices. We have 7 nodes. Okay, now we got back the answer, not friends. As you know, they are not connected, so they are not friends. Now let's introduce this edge. There is an edge between Sam and Ben, and see if Sam and Charlie are friends or not. So what is this edge? 0, 4. 0 is Sam, 4 is Ben, right? 0, 4. So let's introduce this edge. Now, theoretically, they should be friends. And they are. Clearly, there is now a path between Sam and Ben, and then we can reach Charlie. So they are both friends. Okay. So that is the C++ implementation of disjoint sets. So I hope it is clear, the theory and implementation. Do practice it so that it is more clear for you. If you have any questions, definitely ask me. Don't forget to leave a like if you found this helpful. Do comment if you have any questions or suggestions. Thank you so much for watching. I will see you in the next one. Cheers.